All right, what's up, everyone? Thank you so much for coming today. I'm really excited you're all here. This is our fourth session, and we have almost 200 people registered. We have people of all demographics, ages, and locations attending. My name is Julia Lieberman. I am a computer science major at Santa Clara, four-time Microsoft intern, and looking to start interviewing at other companies just to see what's out there as we start to enter the actual workforce. And I thought this program would be helpful to everyone who's also in a similar boat and looking for full-time jobs or internships. So today we are joined by Brian Helba. He is a staff R&D engineer at Kitware, and he has 9 years of experience developing open source software for medical research applications. He's hired and supervised software development interns for the past 5 years, and judging just from my brief interactions with him preparing for this call, he really knows his shit. So without further ado, Brian, I'm going to hand it over to you. Thanks for joining us.
Absolutely. Yeah. And thank you so much, Julia, for inviting me and the opportunity. And thank you, everyone who's here. I'm looking forward to, walking through this interview. I think I'm going to spend some time in the beginning talking about myself, talking about the company I work for, Kitware, talking about our internship process. I think it's going to be a little different than what we've heard about before because I work at a much smaller business than some of the other, presenters that we've heard from in the past. And then also we're going to walk through an interview process itself. We're going to take about 45 minutes. Julia's going to interview me, and I'm going to sort of solve a problem here on LeetCode. And then the rest of the time we'll be around for questions. And I'm happy to stay, afterwards and chat with people on stream, and then, talk to people afterwards if there's any follow-ups. So I have a little bit of a presentation just about myself to share. I will go ahead and share this. Great. Okay, I'm not going to try to make it full screen, so you'll all see the Google Docs background, but that's fine. So I'm here. I was invited by Julia for cracking the coding interview. Let me talk a little about myself. So 9 years ago, I graduated with a bachelor's in biomedical engineering computer science from RPI, Rensselaer Polytechnic Institute in upstate New York. And actually, that's where I've been ever since. So I've sort of stayed around the area for a while now. And I've been working for 9 years now as a software developer. I initially thought I was going to go a little bit more into like sort of the hardware and electrical engineering side. But in college, I got really into open source software. I, installed Ubuntu on my laptop when I was a sophomore, and I sort of got much more into that world over time. And I realized I really enjoyed like the freedom of software. Another thing I'll say, which I didn't put on my slides, but I'll freely admit, I was never like a really enthusiastic about the structure of school itself. I always really enjoyed doing projects. I enjoyed doing practical work. I didn't really enjoy a lot of the classwork. I'm really fortunate, I think, to have found an industry, like our own software engineering, where you can continue to learn new stuff every day, but you can be self-taught, right? There's so many resources out there to structure your own learning. It's not that the only path to advancement, the only path to knowledge is from the classroom. So I think it's important to absolutely like have some classwork, have a good foundation, but I think you can make an entire career where you can continue to develop and grow and not necessarily have, it all given to you via a degree. But more about where I came from. I've been working sort of medical imaging and data management in my current position at Kitware. I'm a staff R&D engineer now, and for maybe the last 5 years, I've brought on anywhere from 1 to 3 interns. I mean, usually on the higher end, but a couple of years we've only had 1 interns per summer or for longer co-ops, and supervise them all the way from the hiring to the sort of end evaluation process. Let me talk a little about Kitware. I don't blame you if you haven't necessarily heard of us. We are a open source software solutions company, and we partner mostly with people doing scientific and research and development projects. So that means people everywhere from like sort of the government world of national labs, government agencies, to semi-private things like universities, hospitals, all the way to like, large commercial companies, all of which are doing some kind of science R&D. And, nowadays, if you're doing scientific research, you're probably using some software. But you probably are, while you're a domain expert, you have a PhD in chemistry or biomaterials or whatever else, you can use some MATLAB, you can maybe use some R. You're really not that comfortable with software engineering practices. And that's where we come in. We partner with domain experts and bring our software expertise to build actually like sustainable software. Another interesting thing about Kitware is what we do is open source. Certainly we get hired by some companies that want to keep their stuff private, but our foundation is open source software. So we were founded 22 years ago on the back of VTK, the Visualizations Graphic Toolkit, which was an open source toolkit. It's still around today to do visualization of, sort of everything from like lighting and actors all the way up through like advanced rendering techniques. We have a couple locations throughout the US, and we have about 200 employees and then hire about 30 to 40 interns per year. I'll finally say about Kitware, you may have heard of us if you've used CMake. So if you've done any C++ development and you use CMake to configure your make files, well, that's our product. But since it's open source, it's distributed, all over the place, and we maintain it. But we have hundreds of contributors around the world who help us to also work on it. And then other sort of more scientific domain specialty things include BTK, ITK, and ParaView. If you've done anything maybe in a computer graphics class or like a medical imaging class, you might have heard of some of those products as well. So let me talk about our internship process. So we typically put up job postings in maybe September through November. I often will go to career fairs, maybe in, August through October as well, to sort of, hype up our job postings, talk to people, gather resumes, do some pre-filtering. I'll tell you, I gather resumes from job fairs. Most of what I end up doing is in the 2 to 5 minutes that I end up talking with candidates, I'll get some sort of initial impression, and it's almost never a bad impression. But if it's a neutral impression, I'm just going to put the resume in my folder and pass it on to HR. But if you make a good impression, I will absolutely make a note on the top of it and say, this is a really promising person, and I will put that on top of the stack. I'll pass that on to our HR team, and I'll say, this is a really worthwhile person. Maybe you should reach out to them. Maybe you should follow up. But really, if it turns out to be not such a great interaction, it's fine. You're free to apply anyway. And honestly, I'm probably not going to remember any negative interactions. I might just remember a really positive one. But whether it's because HR reached out to this person because I was excited, or you apply to us, you apply on our website. We try to do interviewing around like the November to December timeframe. And by the way, this is all for the following summer, I should say. We'll do that interviewing over the phone. There's typically like a 30-minute HR screen, which is where one of our HR people, a non-engineer, reach out and be like, okay, are you a real person? Is this, are you able to sort of talk coherently? Are you able to talk intelligently about the work you've done before? Your work as a student, any previous job experience that you may have, etc. You don't necessarily have to have previous experience as an intern, but we typically do like to see at least some independent project experience. In some cases, that could be some coursework you did that really was just an amazingly beautiful project, but it could also be some open source project you've contributed to, or maybe some extracurricular thing. A lot of people maybe have a club that they work with who they designed a website for, or maybe a coordination, some coordination software or something like that. But we like to see a little bit more, well-rounded and passionate people. And then afterwards, we'll generally do 1 to 2 hour-long technical interviews, and I'll try to cover, and those will be conducted by me or one of the other intern hiring managers. We'll try to cover a few things. I'll first say, tell me about yourself. Talk to me about, your background, what you've done. And this is absolutely, I think, where it's critical for people to have that, 60-second elevator pitch, right? You don't necessarily have to be a completely unique person with independent research interests. You just have to sound passionate about something, right? Even if you've been like, well, all I did is I followed the standard courses. I went where they told me to do. I did the coursework I was told to do, and I got A's. Great. You can still talk about something that you found really interesting, that you enjoyed or want to pursue more, a course that you really liked, a professor you really liked, just sort of something to say, here's who I am. I'll often also ask you about any projects you did, maybe even if it's a course project that you really just absolutely did an amazing job of, and you knocked it out of the park. Tell me more about that. Tell me what you did. Tell me what your team did. Again, I want to hear that people are able to collaborate effectively. If you told me that you did this entire project by yourself, that's actually less impressive to me than hearing that you're able to work with a larger team, collaborate, communicate, and even get more done. I mean, it's easy to be like a brilliant solo person, but it's better to be really a collaborative professional. And then finally, we'll walk through some code exercises, usually using a tool like REPL.it or codeinterview.io. There's a million of them out there, where we can both screen share. We can both often type into a common terminal. And I'll give some basic problems like, okay, you know, let's do some string sorting. Let's do some stuff with regular expressions. Let's do some things with linked lists. I try not to actually pose incredibly hard questions at first. I want to get people warmed up and ramped up. But then almost always I'll ask, okay, what are some other implementations you could have gone through? Let's compare and contrast them. Let's look at their runtime complexity. How would you evaluate runtime complexity? How would you profile your code in the real world? Talk to me about this data structure you used. You know, I'll use that as an opportunity to launch and go deeper. I think as a major difference between the sort of code exercises that we do at Kitware and the exercises that maybe larger companies do, that you've seen before, and honestly what we'll be doing today, is that I like to be a little more freestyle. I like to talk a little bit more back and forth, as opposed to saying, all right, you have this really big problem and 45 minutes, go. I try to have a smaller problem and do a lot of follow-up. And then finally, the internship process itself, once we've made a hiring decision. Most internships are summer internships for 3 months, although we certainly take co-op students for up to 9 months. You're typically paired with someone who's a mentor to you. They're not ever going to directly supervise your work, but they're going to be there as a resource. Everything from, I'm confused about how to solve this problem. I have a dumb question I'm too embarrassed to ask, all the way through, I need a recommendation letter. I need some, you know, career advice. I'm interested in being hired full time, etc. They're there as a resource for that. And then we usually like to cycle people through anywhere from at least 2, but often up to 4 different projects, where you maybe will be assigned some tasking. You'll attend project meetings. You'll work with other engineers. You'll have your code reviewed, and you'll also review other people's code and attend customer meetings, often as a fly on the wall. And then finally, once the end of the summer arrives, we usually have you give like a short presentation on what you've done. So that's our internship process. I'd be happy to maybe talk, if you want, a little bit more, Julia, if you have some questions or some follow-ups about specifics of how we interview or what I'm looking for, but I think that provides a nice little outline.
Well, we have a few questions from the comments that we could go over real quick, like how many new grads do you plan on hiring and what is the timeline for those roles?
Got it. Kitware is actually, I mean, my company, again, we have 200 employees, but we're actively growing. Now, that's not necessarily growing at the same pace as someone who's hiring, 50% of their staff year over year. But we've typically been growing at a rate of about 30 people a year for maybe the last 5 years. When I started, we were actually under 100 people, and now we're at 200. So we're looking to make about 20 to 30 hires over the next year. A lot of that is depending on what team you're coming out of, and some teams are actually only looking to hire more experienced people. But I'd say we're probably bringing on around 10 sort of entry-level people per year. And then what was the other half of that question?
It was what's the hiring timeline?
Got it. I mean, yeah, so for full-time, an internship is a great start for what it's worth. A major goal of our internship program is to find candidates for full-time positions. And the timeline for an internship I sort of just gave, right, was, try to wrap things up by December for the summer before. And then for full-time positions, it's really any time of the year. We obviously get a lot of people in like the February to March timeline who are anticipating graduating as seniors. And, they'd be starting around like the June, July timeframe. And that's pretty normal. We're pretty flexible as a company. We're actually very open to, accommodating people who want to maybe do even fall or spring internships as well.
Awesome. Yeah, that was another question is, does Kitware hire for winter 2021 internships, like starting this next January?
I mean, so the short answer is absolutely. The longer, more complicated answer is, just like a lot of things, it might depend on even things as like whether or not we have a job posting up. I'm not necessarily, I'm here on my own time. I'm not necessarily here to sell Kitware, but it's a great place to work. I really enjoy it. So we have a jobs@kitware.com link. If you're actually really interested, talk to me afterwards. I'd be happy to talk about that. And you can always just email us and ask about if you don't have a specific posting put up. But so most of our interns come in the summer, but we're certainly open to other times of the year.
And does it matter if that applicant is not in the same state?
Yeah, that's a good question. I think that's something we're all still trying to figure out. So, now with a lot of the work, I've been working at home since March. I've only gone into the office a few times to like pick up equipment. And so all of our batch of summer interns this year are effectively all remote. Traditionally, we've actually asked people to relocate and to move. I think personally, I think it's maybe my opinion is mixed. I think you definitely get something from being with your team face to face. Just being able to walk over to someone's desk and chatting casually, it's a lot less awkward than having to like message someone and scheduling a time to meet. But personally, I'm actually pretty supportive of remote work. I hope that we do more of it in the future. And as for what's going to happen in the following years, once sort of the work at home and COVID passes, I don't know.
Yeah, I think it's hard for anyone to answer that right now. And then one more question, and then we'll move on to the interview part. What have candidates done well and like left a positive impression during career fairs? And do you have any advice for people on how to leave a good impression while attending virtual career fairs?
Great question. So the latter question I can't really answer. I have not attended a virtual career fair before on either end. I will say though, maybe my advice will sort of carry forward into like the screening interview. So I think, like I mentioned before, having a coherent, this is what I am, this is my passion, and it doesn't necessarily have to be software, right? You could be really, I have a friend actually who's very into jewelry design, right? But she was able to take her passion for jewelry design and do a lot of really cool things with like building CAD CAM models. And, she's actually done some business work as well, where she was able to use some software engineering skills to, maintain an e-commerce website and do some other things there. And this is someone who you don't have to have a singular sole focus on software, but to have some sort of passion, some sort of focus of here's who I am as a person is really important. And then also be able to convey that in a 60-second elevator pitch. And I'm for the most part, as long as you're not reading off note cards, I'm fine with people if they are nervous. I'm fine with people if you sound a little bit overly rehearsed or over prepared. I know what it's like. It's super stressful. All I can tell you is that, like, at least on my end, again, I'm not ever judging bad responses. I'm only just remembering really good ones. And then for interviews as well, to make a good impression, I would say, number one, have that pitch in the beginning. And then number two, just be able to like have a little bit of a dialogue, have a little bit of back and forth. Don't be afraid to say you don't know. Don't be afraid to ask questions. Treat it a little bit more casually, even if you are nervous. Would be things that make an impression on me. And I can only speak for myself.
And then actually one last question, because a few people were wondering this. Does Kitware sponsor J1 visas for Canadian citizens? Do you know?
That is, again, another good question. I know that we definitely are open to working with things like H-1B programs, and I know we've done that before. All of this is sort of in the HR, scope, and it's outside my expertise, and there's all sorts of regulations that I can't pretend to understand there. I'm going to say, like, reach out and ask, right? And that would be something that if you email jobs@kitware.com, we'd be happy to answer. But I do know that in general, at least for full-time people, we've done H-1Bs. And I know also, and I can't speak about the details. We have an office in Lyon, France, and we've often had French interns from there come over to the US. And often the French educational system is interesting. They have like this 5-year system where it's like 2 years of general education and 3 years of technical education. And so we often get people who are like 1 to 2 years into their technical side come over for like a year-long internship. And I know the French system is much bigger on co-ops. So I can say we sponsor that. I know less about sort of like, interchange along the Canadian to US side, but I think we'd be pretty open to it as long as the legalities let us.
Awesome. Okay, let's jump into this interview. So for everyone who's attending, you guys have seen now we've done a few different formats. Today, I'm going to interview Brian, and I have 0 interview experience, but bear with me here. So, hi, Brian. Thanks so much for coming to interview today. Super great to have you. You want to tell me a little bit about yourself, and then we'll jump into some questions?
Definitely. So, as a meta note, I'm going to sort of, I'm not going to try to be a complete actor, complete role player here. I mean, I will speak about myself as though I had some experience and I was interviewing as I really was and not as though I was just graduating. But I am going to try to like assume the mindset of someone who's in an interview. And then maybe we can talk later, but at the end about my performance. I want to hear from Julia what she thinks I did well. I want to hear from all of you about what you think I did well, and also even what you think I could have improved on. I'm here to be your guinea pig. So anyway, so I'll start again briefly because I introduced myself at the beginning of this call. So hey, I'm Brian Helba. I've been working for 9 years now as an R&D engineer, doing collaborative scientific software. I started out, I thought I was going more into sort of the electrical engineering and hardware track, but over time I really developed a passion for software and particularly open source software. I've worked in a lot of different programming languages over my career. I started more in the C++ world. Now I'm actually doing a lot of work with web technologies and designing large scalable applications for data management. And oftentimes the only way to do that efficiently is on the web. I'm now sort of, even though I'm an engineer, I'm also a project lead. So I spend about half my time doing coding and about half my time doing sort of project management. And that can be everything from budgeting to doing code reviews, to doing mentoring, to helping to plan out timelines and deliverables for my team on a technical basis. And I'm here today to interview for a software developer spot.
Awesome. Sounds like you've worked with a fair amount of technology. So I'm interested if you can tell me a bit about a time where you had to learn a new technology on your own. What resources did you use? What was your learning process like? How did you start?
Yeah, great question. So a lot of times when I'm learning something on my own, I have a goal in mind. I need to bring X capability into my project or into my team. And then the first thing is I have to figure out what the most appropriate, language or framework or a toolkit is. And so there, I would actually argue that the easier it is for me to learn, the better it is, because that means it's more likely to be adopted by my colleagues. It's more likely to be used effectively by my team. So I'm actually, for professional purposes, not really interested in learning really difficult, really hard technologies unless the payoff is really there. So one of the first things I look for is like, is there good documentation on the tool itself? I'm usually looking for something like a tutorial or a quick start guide. And then I also would look to see whether there is, and I wouldn't read it, but I'd see whether there is like comprehensive API documentation. So if I needed to ask, how does this function work? How does this thing work? I could go and get an authoritative answer. So I'd usually start with the tutorial. I'd walk through some examples. I'd maybe actually stop there and try to use it myself, try to install it myself, try to use it on a project. And then I'm sure would have some more questions and get stuck. And that's where I probably would jump straight into Google. It's certainly a skill and an art form to figure out what the right thing to Google is, and also knowing what sites to trust. I trust Stack Overflow probably more than anything else. It does not mean that all the information on there is good. It does not mean every answer is good. Often the top voted answer or the accepted answer may still be the wrong answer, but it's absolutely a great starting point for inspiration. I think things like Medium blog posts and other things of that nature are good if you're looking for subjective opinions. If you're looking for someone saying, here's a particular software pattern that I used, or here's a particular like technology comparison that I did. It's not so good for like, how do I actually accomplish X? And then at the end, once I feel like I have some basis for understanding it or for knowing it, I'll often present it to my team. This could be super informal. I might just during a project meeting tell people like, hey guys, I've been looking into this new technology and I've been trying it out and it's been doing this good thing. I think we should adopt it for us. Or maybe I'll try to deliver like a little bit more formal presentation at maybe like a larger group meeting. And then finally, I want to be open to always thinking about, even once I'm really invested in this technology, the ecosystem is changing so quickly that I don't want to hop from tool to tool, tech to tech every 6 months. But I do want to try to keep an eye out that I don't get too stuck in one technology, and when something better comes along, I miss it.
Awesome. That is a fantastic answer. So yeah, Stack Overflow is definitely a great resource, and knowing what to Google, I think that really comes with experience. And I like that you touched on keeping an eye out for other tools that may come in even after you've been using tool X for a little while. If tool Y comes out and that's significantly better, you're going to keep an eye out for that. So yeah, awesome. So let's move on to the coding question. A
Sure.
lot of you, the people here, and also Brian, may have been exposed to the n queens problem, the 8 queens problem. That was one that I learned in my first computer science class at at my university. So it is not an easy problem by any means. As you can see, LeetCode rates it as level hard, but we're gonna tackle it and we're gonna go through it slowly. And Brian's gonna explain his thought process here, and we're gonna do it as though we're in an actual interview situation. So without further ado, Brian, so I don't know if you've seen this problem before, but basically you need to place n queens on an n by n chessboard. And for our purposes, we can start with 8 by 8, which is your standard chessboard size. And the idea is that, in chess, queens can go vertically, up, down, they can go horizontally, and they can also go diagonally. So we need to place all of these queens so that they're all safe. None of them can kill each other, but we need the same number of queens that we have number of rows and columns. So you can choose whatever language you're most comfortable in, and if you have any questions, feel free to ask me, and we can work together towards coming up with a solution. And it doesn't have to be the best solution, but I do want you to think about your design before you actually start coding, and I want you to walk me through your thought process.
Got it. Thanks. So, when I'm designing something, my first thought is how do I want to represent the problem in code, right? So, we obviously see this chessboard. It's visually great. I think there's probably a representation of this problem that's most efficient for the computer, but I actually don't want to go straight towards that. At the end of the day, like, computers exist to serve us, and I want to come up with a representation that's going to be best for me to work with and to debug. And then once I solve the problem, I'm totally open to optimizing it and thinking, oh, maybe using a different data structure that's a little less intuitive to humans, but a little bit more efficient for computers might be better. And I can refactor my code and I can make it, maybe solve it even more efficiently. So first of all, I see a n by n board, and each case there's either a queen there or not a queen there. So now I'm thinking of a two-dimensional array, and a two-dimensional array in particular of bools, right? And maybe let's just say that true equals a queen in that space and false equals no queen at that space. I could also deal with like ints and have 1 for queen and 0 for not, but let's just think about bools for right now. And I think I'm going to be looking mostly here at random access. I don't know that for sure. I think maybe eventually I might end up in a situation where I don't need to like hop and access squares randomly. But right now I think it's going to be pretty much random access. And so I think just a two-dimensional array or vector is fine. I don't need something more special than that. So that's representing it. Next, let me think about the approach to solution, to finding a solution. Again, I want to start with the easiest approach, right, which is brute force, which would be I want to assume an empty board. Okay, I'm going to place a queen on every single possible space. Oh, someone is drawing on the Zoom board, but I'll let you figure that out, Julia.
What? I did not even know that was a thing.
Cool. I'm going to keep going, and I'll let you troubleshoot.
Yeah.
It's the board. It's not bothering me. Okay, so we have a brute force approach where we try to place a first queen in every possible space. We then place the second queen, and we look, okay, is there any place that I can't place it? Skip that. And then I try to place it in every other possible free space. And then the third, and then the fourth, and then the fifth. I fully expect that like a lot of these possibilities will be fruitless, right? It may turn out that this particular initial space for the very first queen will be will never yield a configuration that allows me to put 8 on the board. Okay, I'm fine with that. But we want to think about conceptually brute forcing it. And by the way, for what it's worth, this is basically going to be like n factorial combinations, right? Because we first have 8, different ways of doing each one, and then 7, and then 6, and 5, and 4 for each of the remaining queens. I think also there's going to be a more efficient way to do this, but let's maybe start to come up with the tools for the brute force solution, and then see ways we can refine it and make it better. So one of the first tools that I want to do is something to debug, aka a print statement. So I want to come up with something to print the board. And is it okay with you, Julie, if I start sort of typing? Great. So first, I want my code to be valid. Another thing I'll say is I'm not a huge fan of how LeetCode has used a class here and a member function. I think, you know, object-oriented programming makes sense and maybe even makes sense in this particular case, but like we're not using this solution to like be instantiated. We're not actually assigning anything to self. It looks kind of just like a wrapper. So I'm just going to start by making flat functions at the top. And then if we maybe need to inline them into the class, we can. But otherwise, I'm going to make a print board. And you know, another thing we didn't walk through in this is like the choice of programming language. I'll just say right now, I'm going to choose Python. I work with it a lot. I work with it almost every day, and I'm pretty happy with it. If we were doing something like C++ or JavaScript, you know, I'd be maybe comfortable with those too. But I think Python has a nice set of data structures built in, and it's pretty like syntactically concise, so I don't have to put a ton of boilerplate like Java, you know, just to get the most basic functionality. Okay, so I'm going to print a board. It's going to have a board, and we'll talk about what that is. And I'm going to use some Python type annotations just because they help me to program. They're not necessary. They're not checked by the actual compiler, but they help me as a human being. Given a board, I'm going to assume it has like, you know, sort of this configuration, X and Y, and actually maybe we'll call this I and J. And so our board is going to be a list of lists of bools, right? And then I can now iterate over the board. So I can say for, and I can actually probably use some fancy Python enumeration here, which is like for row in board, and then for space in row. And then I can print. So let's see here. I'm going to print a dot, it looks like, if we have nothing there, and then otherwise I'm going to print a Q if there is something there. So actually I'll say I'll print a Q if space, and again, space is a bool at this point. Otherwise, I'm going to print a dot, right? And then also this particular thing, I don't want a new line. So I think I can, I don't remember this exactly off the top of my head. Normally this would be something I Google, but I'm going to guess that I can pass this kwarg of end equals nothing, and then print is not going to do a new line. However, I do want to do a new line after each row. So sorry, I want an empty print there, and I also messed up some of my syntax, so we'll fix that. And then finally, once at the end, I'm just going to have a final new line just to sort of make it a clean print. Let's also, in terms of utilities, make an init board. Actually, just call it create board, right? So that's going to take nothing, and it's going to return. And actually, since I'm sure we're going to be defining this board a lot, let's just define a new type. And again, these type variables are not necessary at all. They could be checked by like an analysis tool like MyPy as part of basically like a linting step, but they really help me as a human being remember what different stuff is, what different variables are. So this is going to output a board. And let's see here. So we also know that this is going to be a size n, which is going to be an int. And then we're going to make an n by n thing, and it's going to be bools. So it's going to be, we're going to take false. And if you multiply by 8 in Python, this will just give us like, actually, sorry, not 8 by n. If you multiply by a number, you'll get like false, 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 false. And I want an array of that. And then I also want an array of arrays of that. So I can do a fancy comprehension for some empty thing in range n. So this is going to loop n number of times. Each n number of times, it's going to give me a new array of n number of false things. And so we have an array inside an array. Each of these are a false bool, and we can return that straight away. Already, I want to start by testing out some of my code. So let's try and see what happens. So I'm going to make a board equals create board, and we can go ahead and pass n, and then I can say print board, and let's see if this works, because I don't want to get too far in and only discover I have an error. Okay, cool. So I have for an input size of 4, which LeetCode is giving me, I'm getting an empty board. Great, good so far. Next, in terms of like utilities that I know I'm going to need, I know I'm going to be able to need to check whether like you know, a particular board is valid. And although I could just like sweep over the entire board and say like, is this whole board valid? What I think I really want is the ability to say, like, can I place a queen here, right? So maybe I want to say can place on board, and actually this is a little bit verbose. I have to type this every time, so I'm just going to say can place. Okay, so given a board, I want to ask, can I place something at space, maybe I, and again, I is an int, j is an int, and it's going to tell me an answer, which is a bool, like yes or no. And for right now, I'm going to see if I can minimize this code checker thing. There we go. Found it. Okay. So let's see. So I know normally that I have to look. So let's just stub out, like in almost pseudocode or algorithm, code, what I need to do. So I need to check, can I place this vertically? Can I place, well, let's just say vertically, horizontally, and diagonally. All right, so vertically. I haven't really defined here which of I and J is vertical and which of I and J is horizontal. I could, but I really don't think it matters because at the end of the day, it's fully symmetric. So I'm actually just going to sort of think about, like, can I place this along I? So I'm really thinking it's like for a board, for a given I, can I place it at any of this, is it valid to put it here? And actually, I realize I'm sort of explaining this poorly. Here's what I really want to say. Given a board that has existing stuff, if I place a new thing at exactly ij, will there be a collision? Will there be like a check or a taking possibility vertically? Will there be a taking possibility horizontally, right? So what I really want to do is I want to sweep along every single one of these and see if there's anything else at this same location. Then I know that could mutually take, my queen, and it'd be bad. So what I really want to say is like for, and let's just use another, actually let's now, I'm already getting confused with I and J. So let's just say row and call. Okay, and we're going to arbitrarily call this row and arbitrarily call that one call. So now I can say for, and actually another thing I need to know is what is n function, right? So I can get n by looking at just the length of the board. And the cool thing is, since the board is symmetric, I can actually only look at the length of this outer array. That'll also give me the length of the inner array. Okay, so if I look at some counter I in range board, and by the way, for what it's worth, usually when I'm doing Python, I try to do like this fancy iterator style, or I do this fancy comprehension style. But oftentimes, if I'm just doing like random access, I want to just do an old school, like, array indexing. And so let's stick with that for right now. So I'm going to keep row fixed and locked, and I'm going to sweep this I, okay? And if at any location along this sweeped I find something, so in a given row, if I find something along any other I in that given row, uh-oh, not good, return false, okay? And I, for right now, will also stub out the horizontal solution. So then again, that's for a given I at a given column. I'm going to check it. And this actually, I didn't even think about this. I got to think for a second in my head, like vertically, what is that equal row? So for a fixed row, and I'm sort of just a visual thinker, so I'm like playing here. So for a fixed row position, I want to sweep along every single different I in the location. So actually, that's kind of like horizontally. But maybe I'm getting this backwards. It's not particularly important. I'm actually happy with my code. And I'm gonna press on here in the interest of time. So diagonally seems kind of hard. So let me think about what a diagonal even means by definition, right? So I think what a diagonal means by definition is for a given location, like again, I, J, well, let's just start with row and call, okay? Possibilities for like a diagonal would be like row -1, call -1, right? Row +1, call +1. And I think that the pattern's also then repeat like -1 +1 and +1 -1, right? So I have like these 4 different directions, right? The 4 different diagonals that I have to like go outwards on. That's kind of hard or at least it's gonna be a lot of copy and pasting of code. right, to do these 4 different possibilities. So maybe right now, let's stub out the possibilities, but I'm not going to fully implement them because since I've heard of the n queens before, I know that there's a little bit of a trick to where I don't have to exhaustively solve all of it, but I want to kind of have like a stubbed out implementation that I can refer to. And this is another like important principle in software engineering, which is if you've ever done like recursive problems before, one of the steps in is like assume it works, and then use the fact that you assume it works to design the rest of your solution. And another term for this is like abstraction, right? Can I treat functions as black boxes? They have a simple input, they have a simple output. How they work inside, I don't know, I don't really care. It does its job. And if I can stub out here like a black box can place function, even if I don't finish the implementation, I can move on. And if it turns out that there's a trick later on, I can maybe do can place in an easier way. But let's just finish stubbing this out. So -1, -1, +1, -1, +1, -1, sorry, -1, +1, and +1, +1. And by the way, these +1s, and maybe we won't even fix it, but we're really talking about like arbitrarily like I and J, right? So really we're like sweeping along all of the, oh, you know what? I got myself confused. I don't want to actually have a different I and J. I want to have the same I and J. So for every single like +1, +1, +2, +2, etc., I'm always going to sweep outwards by like symmetrical steps and get bigger and bigger. Okay. And then finally, if any of these, if all of these tests pass, I know I can't place it there. Let's do true. Okay. Finally, let's make our actual solver. So I got to think for a second about what I'm doing here. Let's start in the interest of like simplicity with like solving one solution, but it looks like the elite code problem here wants me to give all possible solutions. But let's just start with one for a second. So what do I know? I know that I'm going to be taking in n as an input, okay? And I know that I guess I'll be taking an initial board, right? Since they're giving that to me. So board, since I already have a function for that. I maybe could call create board inside solve, but right now let's just call it outside solve. So for what it's worth, I can already start to think about how I'll call solve. I'll call solve with n and with board the same way down here. Okay, so what do I want to do? Well, again, the naive like brute force solution is to try every single space, try to place something there, and then, you know, iterate further, right? And actually, now that I think about it, since I might want to track like which space I'm on, so I maybe have a thing which is like, you know, queen num, right? And I'm going to start on queen number 0, and I'm going to like increment that over time. I think that would be helpful to do, right? So at the very least, I think I might want a for loop, which is like for, you know, queen in, well, you know what? I'm going to start here for queen, and I'm going to make it actually counter. So for queen num in, I actually need an n. So n is the length of the board again, range n. Okay, I'm going to do some stuff. So here's where I think it's going to start to get cool. I know that I can have a trick to solving this. I don't need to check every single space in X and Y. What I can do is I can basically say, I'm always going to assign exactly one queen per column, right? So column A is always going to have one queen, column B always going to have one queen, column C, column D. So I don't need to ever check to see whether there's a duplicate queen in A. I will always place exactly one queen in A, always a one queen in B, always one queen in C. And I also know that if I sort of break this down and start with like a 1-column board, right? So I'll have a like 1 column over an 8-row board, okay? I can always place a queen there. And then if I expand that board by 1 and add a 2nd column, I can find a location, hopefully, where I can put a queen there. And then I can, and I know that if everything to the left of my new thing is already valid, I don't need to recheck it. I only need to recheck the next queen. So I'm always checking only the marginal, like next queen, where can I put it on the next column? I don't need to recheck all of that stuff, right? So in other words, if I already have a like, you know, 6-column board, right? If I add a 7th column, I only need to check that 7th column. And if that 7th column is valid with respect to the rest of the board, I don't need to recheck the whole board again, right? Another thing that occurs to me is like, since I'm probably going to be doing maybe some backtracking, since I might make some mistakes, since I might put some queens in the wrong place and be like, oops, I need to undo that. Explicit backtracking is possible, where I like every time I make a bad guess, I could set that value to false and continue. But recursion actually could solve this for me really well, right? I think also recursion makes sense because we're sort of splitting this up into smaller subproblems. Like the super classic recursion problems, you're just partitioning everything by half, or you're partitioning everything into equal sizes, right? You're doing like merge sort, or you're doing like some sort of, depth first search or whatever else. But in this case, we're not always like partitioning it equally, but we are partitioning it into the entire board that I've done before. What is one more column? The entire one more column, right? So let's maybe think about how this solve would be done recursively. So I know for a fact that I'm going to start, so maybe actually I want to start by passing in what queen num I'm on, right?
And let's make sure also that I see you've used n now twice in the beginning of this. You pass it in as a parameter and then you redefine it.
You're right. I kind of messed up there. Thanks for pointing that out. So actually n, so solve I think is going to be a very general purpose thing, but I realized that with the length of the board, I actually don't need n. So let's just get it dynamically, and it simplifies the solution. Cool. So let's just say solve like only for the first queen. So we're always going to put the first queen at the first row, okay? So I'm probably going to change this in a minute, but let's just say, so the first queen, I will put that in the first row. So queen num, right? And then I have to figure out which of these it goes into, right? So now I can sweep for, let's say, every single possible space I in range, and actually I got to redefine n there, len board in range n. I can now try if can place, okay, and then the star obviously is my variable. Okay, so I'm definitely going to pick always this first, and I keep saying row and column, but let's just say, since we define this one as row, I'll just say I'm going to lock down the first row, right? So I'm going to lock down the first row. Queen number 0 goes in row number 0, can't change, and I'm going to try all these different possibilities. So if I can do that, then I'm actually going to do that. So board queen num location equals true, okay? And I am going to do that, and then I'm going to advance to the next one, right? So what I actually can do is I can, since I'm doing recursion here, I probably want to make a snapshot of the board and make a copy. So I want to copy board, okay? And new board, right? And let me make a quick copy board function. By the way, I'll point something out. If I were using something like NumPy, it's super easy to make copies of like two-dimensional arrays. Since I'm only using like basic Python built-in libraries, I'm going to have to explicitly make a copy function, but it shouldn't be too bad. Def copy board. It takes a board and it gives a board. And of course, in Python, since arrays store references and not values, we've got to make sure that we go all the way down to things that are primitives, aka booleans, and rebuild a new list. So actually, copy board and create board are going to look very similar, I think, in that we're going to probably want to return a new list, right? And the way we're going to get our new list is for every row in our old list. So maybe we'll just call, let's just call this row in our old board. We're going to then say create a new array here, okay? And oops, I keep typing P. And then for each row, I'm going to say for each space in board space. So here's what I'm doing. I'm sweeping over every row of this. I'm sweeping over every single space of this. And I'm just returning the same true or false. And since true or false are primitives, they're not shared. But since everything else is having a reference, it is making a copy. So I think this works. If I had more time, I'd probably want to test out copy board on its own and make sure that I did it correctly. But let's just press forward here, and if we have to debug, we will. So we have this coming back to solve. We've definitely decided that it's gonna live on the queen number 0 or queen number X is gonna live on row number X. We're sweeping across each column. We made a copy of the board, and then we can actually just solve it again. So I'm going to pass the new board, and except now queen num plus 1. Okay, so we're going to increment the next queen. And then let's see here. Now, this is going to obviously keep going and keep going and keep going, so we need some kind of base case of our recursion, right? So if queen num is n, we are done. So let's just start right now by printing it, and then we'll worry about how do we return it. Okay, so if I got to queen number, if I got all the way up to n, and I didn't, make a mistake, and then the algorithm didn't decide that it quits, it can't place anything more, I'll actually just try to print board of the current board. And then let's think about times in which the algorithm can fail. So I'm going to go all the way into here. I guess a couple times I could, probably as I get near and near the end, as I get to like queen number 6, 7, 8, I might end up with like a board state where nothing can be placed. And it's just all of these ifs are going to fail. It's going to run through the entire loop of this. It's not going to recurse at all. But that's cool. It's just going to pop back up, and those sort of branches of the tree will be like just pruned off, right? And it's only the branches that reach all the way down to depth equals 8, all the recursion that reaches all the way down to depth equals 8, that will succeed, and it'll print the board. So I think that will work. And then let's actually try to solve this guy. I realize now that queen num needs to be started with something, so we're going to start with queen number 0. And then let's try to run this. I haven't ran my code in a while, and oh, you know what? I totally realized I forgot to implement can place. Okay, I'm glad I didn't even press that button. Otherwise, I would have looked silly. So let's think about can place and diagonals. So I think that I can make things simpler now, because I know that can place, it's never really changing this first queen num, right? So this row is actually always staying the same, and it's this column that's always like changing 1, 2, 3, 4, 5, whatever, right? So let's think what that means. That means that for each new row, there's never going to be anything else there, right? I'm never going to find a collision on row. So actually, this whole thing, that whole check is kind of pointless, right? And I am certainly going to need to check whether anything exists on like other, well, let me restate this. So for a given queen num, we know that that queen owns that row, okay? So along the entire sweep of that row, for any I within that row, we're good. There's no other queen. However, for other columns, as you move back and forth, there may be a queen there that can take horizontally. And I now talked about this problem enough that I'm comfortable saying that this is the horizontal case and this is the vertical case, I think. I'm under a little pressure here. I'm a little nervous, so I might still have gotten this wrong. Well, let's think diagonally now. I think I can prune out 2 of the cases, because again, let's think about this. For each queen, I know that there's nothing like in the empty space in the frontier, right? There's always going to be this board, like as I'm moving, let's say, like left to right or top to bottom, along the things that are pluses, along the things that I haven't got to next, it's open. Everything's cool there. There's going to be no other takings. It's only in the past. It's only in the the area that I just left that I already had a board on that I need to check. Okay. So what that means is I definitely need to check the minus case. Okay. So let's actually do that first. So for I in range board, if and I can actually just steal this right here. Okay, if that exists, return false. However, I got to think about the fact that I could easily be running out of bounds, right? I mean, row is obviously not going to be equal to 8 every time. Column's not going to be equal to 8 every time. So sometimes this might hit, a negative number and go out of bounds. So I should probably check that. A cool thing about Python is you can actually do this like multiple comparison. You can be like, if I is in the range of n, you can do like that, right? Where obviously I has to be greater than or equal to 0, but I is still less than n. It'll satisfy me. I mean, realistically, I probably don't need this full bounds checking, but it'll be nice. And actually, I'm checking row I and not I. Yeah, there we go. So if this index is between 0 and n, we're cool. And if this index is between 0 and n, we're cool. Okay. And then I know I'm going to need to do the one other one, and I have to think about which one it is. So I know it's not I plus 1, because that's always the frontier. We're always going to the future. So it's either one of these two. I got to think about real quick which one it is. So again, we know that this first row is always locked down. We know that nothing will ever exist in this same first row. So and everything above this first row, the pluses, it will also be safe. So I don't need to check this +1. I do need to check the minuses here. And then columns are there could be anything anywhere. So it's actually this case that I want to check next, okay? So let me actually just put some comments here. Okay, so this one I'm now doing column +I and column +I. And again, since I put this double bounds, if I gets too big, it'll break here. Or sorry, if the column +I gets bigger than 8, it'll break here. And if the row -I gets smaller than 0, it'll break here. I mean, I suppose I could have done this, and it's probably marginally more efficient. But I kind of like just having like strong guarantees. I don't have to think too much about what's happening. And realistically, it's not that much complexity for the computer to check one final thing. So I think we are good. Let's try it out. Okay, I have some invalid syntax, no big deal. I forgot oops, let's see here. No, it's there. Okay. Can place, and actually I saw another bug. So first of all, can place needs to take 3 things. It needs to take a board, and I shouldn't be passing it like this. Also, I realized if I print the board, it's time to return. We should not keep going. And okay, more debuggings. Let's see here. So line 27. For I in range board, nope, range n. And let's see if I made that same mistake everywhere else. I did. I made that quite a couple places. So always range n, okay. Cool. So obviously maybe the output isn't there yet. And let's comment out that printing and see what happens. Okay, so I have not reached the solution yet, and I'm not sure why. So let's maybe try to print some intermediate board states. Okay, so every time I get to solve, let's try printing the board and let's see what happens. Okay, so I start with zeros, and then I end with a ton of queens, and I get nothing in between. Oh boy. Maybe I copied the board wrong.
I'm wondering if you even need to copy the board here. Why are you doing that?
Good question. So my worry is that, and I think I found my bug actually. So my worry is that if I place a queen here, I want to maybe make another iteration where I place a queen somewhere else. And actually, I realized where my bug is for what it's worth. I should have copied the board first and then made it here. I think I wouldn't. I don't think I necessarily have to copy the board. You're right. What I could actually try to do is after I've solved it, I could try to undo my work, right? Okay, and proceed to the next iteration, right? But obviously, if I don't copy the board and I don't undo my work, then I'm just going to end up accumulating like, multiple truths in multiple different positions on a given space. I think it probably, well, you know what? Yeah, because here's the thing, right? So like for a given space, maybe I could put it at like row. So let's assume I'm going like column by column, and I'm working on column B. Maybe I could put it on 7. Maybe also I could put it on 4. And maybe both are equally valid, or maybe actually 4 is the good one and 7 is a red herring. If I put it on 7, I won't be able to solve it anymore. The problem is if I pick 7 and I don't undo that work and I don't also try 4 in the same loop, then obviously it's going to try to place it on every other space. It's going to try to place it on 4. It's going to say, nope, I've already done 7. Or in realistic, this is counting up. It's going to first look at 4 and then say, nope, I can't do 7. So I think it's fairly important that I try all of the different possibilities as opposed to just picking the first one. And in like algorithms world, this is called like whether it's a greedy algorithm or not, right? Some algorithms are greedy, and that if you always just pick the first opportunity and go for it headlong, it's great. And honestly, and Queens, there may be a greedy solution, but I'm kind of being very conservative in my problem solving here, and I want to try all of the solutions as opposed to just going headlong into the first one and sticking with it and having no mechanism going back. So let's now try to run the code. Okay, things are getting better. I now seem to have multiple rows. So I know I can print the board here, and that's good. And then this probably isn't returning. That's okay. So maybe let's try putting some more print statements in all of these different ones. So let's maybe put a print inside this loop and see what happens.
And maybe we should check that copy board.
Good point. I might have messed up copy board. I'm going to be honest. That seems like a really good place for me to mess up because I was in kind of a hurry. Oh, yeah, I totally put. Let's see. Oh, no, I was looking at create. Let's see here. So copy board. I take in a board. You know what? I think a better solution would be this list comprehension. But since I'm really nervous about this, I'm going to try doing a safer way, which is to create a new board and then more explicitly, assign stuff into it. So I'm pretty sure that create board works. So let's reuse that. Equals okay, and then let's just go through. So for every single row in the old board, and then, well, actually, let's just do straight iteration. That'll be easier. For I in range n, for j in range n, if board I j, new board I j is true. Yep, let's try that. Oops. Oh, and I should be returning true. Sorry, I should be returning the new board. Okay, looks like things are getting better. I'm now placing a queen, I'm placing a queen, I'm placing a queen, I'm placing a queen, things are happening. So I definitely had a problem with copy board before. I'd like, again, in a real world, I'd like to come back to this eventually, but I don't know if I have time here. And I don't know if I have time in any kind of interview situation to fix all my mistakes. I'd rather get it right than get it perfect. And okay, so let's actually see if maybe I'm getting close to a good solution here by not printing every single one of them. Maybe I will just solve it and then rely on the final board being printed. And let's see what we get. Ooh, I like this. Wait, did I have another print statement in here? Oh, okay, I see what's happening probably. It's looking at a lot of different final configurations. And actually, I think some of these final configurations look valid, some of these final configurations look invalid. So for some reason, I'm allowing invalid configurations to go all the way up. And actually, look, I'm seeing things that are all in the same row here. I'm seeing things that are all in the same thing here. So you know what? I might have been a little bit, I might have made a mistake. Maybe the vertical is allowed and the horizontal is not allowed. Maybe I got those messed up. Let's just try it out. And I forgot to change that one. Okay, looking better. Are these legal? Let's see here. I have nothing in the same row. I have nothing in the same thing. I have no diagonals. I think I solved it. Okay. Now I didn't solve it in a way that like makes LeetCode happy, and I want to spend some time on doing that. I also kind of want to spend some time analyzing this a little more because I swear I walked through it and I was really sure that this one was the one that was cool, and this one was the one that wasn't. But I really might have made a mistake there, and I hope that I didn't cause this to make a mistake that would impact the way I solve this in the future. So I'm not super confident in canned place. I want to come back to it, but let's see if we can at least get LeetCode happy by solving all the solutions. So although, so what do we want to do here? We want to have all boards, right? And that's basically this list of strings. They're using strings, I'm using bools, we'll fix that later. And what I really want is for solve to return me all boards, right? So what does that mean? It means that solve is now returning a list of boards. Okay. So what that means to me is maybe we should start by solve boards. Let's make a list here. Okay. And let's assume that again, so let's actually focus on the final of the base case. Okay. If queen num equals n, okay, then I know that the board that I just did is good. So I want to take solved boards, and I'm going to make this plural, okay? And I'm going to append board, okay? And then otherwise, let's see here. And actually, I'm done. I'm going to return. So what I really want to do is return solved boards. And this seems silly, so maybe I'll just return a, I don't necessarily need to have this solved boards. I can just return that, okay? So return a list with the board. Now, let's look at how solve is doing. So this is now returning solved boards, okay? And in this particular case, I'm not necessarily done. So I'm going to take the existing solved boards, and maybe this is more solved boards, and I'm going to extend my list, meaning tack on to the end of it, more solved boards. And really, this is getting a little bit unwieldy in terms of names, but maybe it's nice to have it separately on 2 lines. And then finally, anything that's in here is a cool. So let's actually think about again what happens. At a given level, it starts empty. It's going to go down through here. Any solved boards from the next level, it's going to accumulate, and then it's going to return all of them. I think this is appropriate, although I need to maybe take some more time to think about it, because again, I'm a little bit nervous. And then I know for a fact that they want it in a different format of list of strings as opposed to a list of bools. Maybe I'll come to that next, but I'm just going to return the wrong thing now, and then we'll go from there and iterate. So this looks kind of okay. There's at least 2 things it looks like, and each of the things look like a board. Let's just try translating it and see if we're getting where we need to. So let's make a def translate board, and that's going to take a board, and it's going to return a.
So we're running out of time here a little bit.
Yeah, sure.
And I really like that you want to go after this. But I think for the sake of time, I really like what you have working already. You're able to get that, you're able to at least come up with one solution. So I think it might be best if we pause here and go back over the solution a little bit and talk about
Definitely.
a little bit more about your design choices and how this is all working. But this is awesome. This is not an easy problem, and you really you really tackled it well, and I really like how you you explained pretty much every single decision that you made, and you
Okay,
were
and I think I was able to come up with both of them here via
okay.
the final step. I just wasn't able to translate it.
Okay.
Okay, yeah, let's talk about it. So how do you want to do this, Julia? I mean, I'm going to sort of like, ooh, take a deep breath. That was not easy. I'll be honest, right? I'll just so everyone knows, right? If you don't mind, I'll give a little bit of background, like on doing this solution. So, Eight Queens was something like I had heard of it, like okay, back when I was like in an algorithms class in school. I never actually had to solve it during an interview, and I have not thought about this problem for the entirety of my career. Julia and I talked about like, doing this. So I sort of spent some time on my own, came up with my best attempt at a naive solution, looked at other people's solutions. Um, I was able to get the basics of like, a basic understanding of like, okay, solve it recursively, do one column at a time. I know that there are even more sophisticated solutions of you can encode the board using like this, array of integers, and there's basically all sorts of more compact encodings. There's also much more like dense solutions. I didn't really want to get into those because realistically, like it would have taken me a long time to really prepare and to focus on that one problem to get there. I'm not trying to discourage other people from doing it, but personally, I would rather like spend my prep time for an interview focusing on a diversity and a variety of questions and being able to solve all of them confidently and really able to talk through my solution than just being able to like have the memorization of this one N Queens in the most efficient form and like bam, 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 knock it out from memory, but also not be able to talk about it in an interesting way, not be able to talk about my programming style in an interesting way. So this is pretty stressful, but I'm actually pretty happy with how I came out. So yeah, let's talk about the solution itself. Do you want to take questions? Do you want to ask questions, Julia? What do you want to do?
First of all, I just want to let you know we're getting like people are typing in the comments right now, and they're all saying like mad respect. This is amazing. Your coding was really impressive, and this felt more realistic than some of the previous sessions where it seemed a little bit more.
Can I please have 5 more minutes? I swear I can do translate board. Okay, let's
Okay.
do that later. No, we'll do that later. If bonus time, I think I can get it, but I don't want to take time right now. All right, let's talk questions.
You were almost there. Okay, let's go back up to the top real quick.
Sure.
Okay, so why don't we have people in the chat? You guys can throw out, first of all, things that he did well and things that sort of like things you would think he could improve upon. And another person is asking if we could have a copy of the code because people want to look through it on their own time. So Brian, if you want, maybe at the end of this, you can save a copy of this and send it to me, and I'll send it out to everyone.
Yeah, definitely. I mean, I'll throw it up on like a GitHub gist or something like that. I'd be happy to send out the link. I don't think I'm signed into. Well, go ahead. I might sign into this in the background.
Okay, cool. So, okay, people aren't saying anything yet, but I think just to throw out things that I think he did really well. He started by explaining the problem back to me, which shows that he understands what I'm actually asking of him. And that way, if there were any gaps, if there was any misunderstanding, that would be a time when I could correct him. And so I really like how he he reinforced that. And then, before actually diving into the solve function, he thought about how can he actually go about testing this and what are the necessary helper functions. And he brought in a lot of different concepts. He talked about abstraction, he talked about recursion, he talked about greedy algorithms, he talked about backtracking. He brought in a lot of different things that demonstrated a wide range of knowledge. And he also used some fancy syntax or syntactical sugar. I don't know if that's a technical term, but that was definitely impressive, a little bit over my head even. So I thought that was all really great. Let's see. We also have people saying, yeah, really good at communicating thoughts and design choices. And I think one person's asking, how well do you expect a student to actually explain as they're coding? You did an amazing job explaining almost every decision, but you're also, a very experienced engineer. So what level would you expect in an interview?
Oh boy. Sorry, I'm sort of bouncing all through the tabs here. Okay, so I will actually share my code right now just to get this out of the way, and then leave that up. Okay, if people want to like, there you go, copy, paste, screenshot, whatever that's what I have so far. Maybe we'll do some more. Okay, so in terms of discussion, so I'm really much more interested in hearing like a basic problem solving process. Okay, a problem solving process would include, yeah, describe the basically like the problem, right? What inputs do you have? What outputs do you have? Talk about how you want to sort of like represent the problem, right? And you can talk about like how the computer represents the problem, but you can also just talk about like conceptually, right? How does our brain, how do we represent the problem? And then I want to think of like, you don't actually have to have in your mind, for me at least, a perfect like end to end, I know exactly how I'm going to get there. I just want to see a strategy, right? And then even in the case of like, you don't have an overall strategy, it's often good to say like, I really wish I had a function that did X, okay? And oftentimes, like for people who are struggling, or I mean, even in an interview, like, if I were really struggling, I would hope that Julia would give me some help and say, hey, Brian, like, would it help if, what do you need next, right? And there's this technique called like rubber duck debugging. I don't know if you guys have ever heard of it, where it's like, if you're struggling with your code, just go get like an inanimate object and explain the problem to that. Explain the problem to the rubber duck. It's a thing. You can look it up on Wikipedia. And like in the act of just talking about it and saying like, hey, rubber duck, I really wish that I had a function that did X. I really did wish I had a function that did Y. You maybe can have a better solution. So I guess my final advice would be break it down into sub problems and then sub problems. And then finally, when you get to a sub problem that you're like, oh, I know how to do that function. Okay, do that function. But I would say also don't be afraid to like talk to your reviewer. I wish I had a function that did X. I can't figure it out. Even that wins me bonus points, right? Like that, I'm already like, okay, yeah. Because here's the other thing about real world engineering, right? Is like you're almost never writing this stuff from scratch. It's I need a library that does this. I need a library that does that. I need a library that does this. I need to obviously understand it well enough to hook it up, but you're not writing low-level algorithms as a professional. You are, however, evaluating code all the time. There are libraries out there that are amazing. There are libraries out there that are garbage. And knowing like, being able to look at the source code and say, yeah, that's good. Yeah, that's bad. Yeah, this is useful. I trust this in my project. Yeah, this looks like it has red flags all over the place. I'm not going to trust this. I'm going to have to write it myself. That's, I think, what we're really trying to get at. So having a sense of like, thinking skeptically, that's also another thing that, and thinking skeptically even about your own code, I think is more important as well.
Awesome. Yeah, we have people saying, they're wondering so you stepped into the code pretty quickly. Would it be better to spend a little bit more time planning, and is going the brute force option the best way if you're unsure of how to go about solving?
Good question. Yeah, I agree. So I'll give another little like, behind the scenes insight here because I want to be transparent with everyone. So Julia and I, maybe a week ago, did like a prep session, right? Where I went through and I attempted to solve this. And in our prep session, I tried to go through I think Julia asked a lot more questions of me. And I think I also like answered a lot of those questions in even sort of more detail as opposed to trying to talk while I coded. And we spent like 45 minutes and we just did not finish. And so I think for something of this size, we realized it's probably better if we just jump straight in and start doing the solution as opposed to talking it out in a lot of detail first. That's purely a matter of time. If you have time in your interview or they give you a problem that's maybe easier, take that time. Like that time is your chance to show off, right? Obviously don't be slow. Don't be like, purposely slow, but feel free to like, I would say like, talk through and get into as much detail as you want. That would be my advice. The other thing in terms of like solutions, yeah, Julia and I did it at first, like the naive, don't assume that a column is free, try every column, try every row solution, and then pared it down. And what ended up happening was I spent a lot more time on this diagonal function, because you obviously have to handle all 4 cases. And I also, this solve function ended up being 2 loops, right? For I in range n, for j in range n, you tried every single one. And then I realized also, like, that's just taking, it's actually longer to write. Like, it's more code to do the easier way. And so I was like, okay, if I can actually do things more efficiently and have fewer lines of code, let's just kind of jump into this. And also, I think that's realistic for someone who had reviewed NQueens, was familiar with like kind of the trick, which is to like assume each brand new column is empty. But maybe you don't have to, like, you don't have memorized this like super efficient, dense solution. I looked at a couple YouTube videos myself of people solving this, and like you'll find professors who like, show you this ridiculously compact solution, and they have all sorts of like fancy, arithmetic to like, or algebra rather, to like let you check a solution in an incredibly dense way. But I hadn't memorized that. I didn't really think that was realistic. And so I think keeping kind of things with like the semantics of it, an actual board, makes sense, as opposed to like an array of integers where each integer represents a position. And if you subtract k, that's the most efficient solution, but that's not a realistic approach to me for real world engineering.
Sure. Yeah. By the way, your screen is glitching out. I don't know if I think everyone can see
Oh, I'm
that.
sorry. Is it better now? I just maximized it.
Yep. Yeah, much
Okay.
better. So I think one thing that would be good is to go over the runtime of this, the big O.
Definitely. Okay. So, let's talk about like what is, so big O is always like usually some function of n, right? So O of n or O of n squared or whatever else. And one of the first things we need to think of is like, what does n even mean? And I had tons of times where I ask candidates like, so what's the, time complexity of your thing? And they'll be like, O of n squared. And I'm like, okay, cool. What's n? And they don't know. So it's an important thing to define, like, what does n even mean? Now here it's pretty simple. N is, we literally have this variable n. N is the size of the board, right? But n is always, in most algorithms, like the thing that could be changing, right? And really what we're saying with big O, and I don't want to get into math of this, is like as n gets arbitrarily large, right? As n like goes upward, 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 what function sort of asymptotically like looks like n. So obviously n equals 8 is not a great example here, but like let's say n equals 1,000,000, what's happening? So for a given n, let's just start by sort of doing some basic like loop counting or whatever else, right? So we're going to go into create board. Create board is going to do something that for each n, it's going to assign some variable, right? So we know already that create board is n squared, right? And I mean, it's even easier to see in places like copy board, right? You have for each n, do some constant time assignment. So at the very least, right now, we have an n squared creation operation. And maybe what they're really talking about is like the solution. And so maybe it's less than n squared, but intuitively, like it makes sense. N squared, right? I'm dealing with this n squared size board. How could I possibly solve it unless I'm looking at every single space at the very least? But maybe there's a more efficient way. All right, so so create board is n squared. All right, solve. So solve, let's see here. I take a board, I grab the length of the board. This, depending on your data structure, could be constant time. It is constant time in Python. It could be, it could be worst case. We actually, like a linked list, we actually have to follow the entire linked list in order to figure out its size. Whatever, let's call it constant time. Constant. All right, so now we have one loop. So we've already accumulated an n. So can place. All right, let's look at the complexity of can place. So can place itself, we have to look at every single space along n and do some constant time thing. So that's n. And then each of these are single loops. So like, so it's n plus n plus n, 3n. But of course, we know that in big O notation, we just drop any leading coefficients. So we have just n. right? And that again makes sense. We're doing 3 linear loops. So each can place is n. Since it's happening inside this loop, though, we already know that we're up to n squared, right? And then with can place, copy board itself is, it looks like n squared. So now since we're doing copy board inside this, we're now dealing with n cubed, right? Because we now have an n squared function inside an n loop. So n cubed, this is pretty much straight up constant time. And then solve here. Oh boy, let's just stub this out and stop and not think about this for a second. And then extend is again just adding a list to a list, constant time, return. Okay, so we already have an n squared operation here. Let me just annotate my code, right? N squared, right? And okay, what's this? So what is solve? So if I, so solve is actually, we're calling solve on n minus 1, so it's decreasing. And I'm actually having this, I'm going to be honest with you guys, I'm figuring this out for the first time right now too. I really had not thought about the answer to this question. But let's talk it through like we're in an interview, right? So we know that if we didn't have this if we didn't have this call at all, right, then solve itself would be n cubed, right? Because this is basically an n, and this is n squared, n cubed. Okay, so for each of these solves, we're constructing, we're going down, we're like, this is queen num plus 1, but we're sort of like making a smaller and smaller and smaller board. And so I'm going to say, I don't think it's going to be log, because we're not like splitting this, right? When you normally use recursion, it's like splitting stuff, then we're getting into logs. Let me think about the base case, maybe work up. So, this is kind of a hard one. Let me let me think about this one a little bit more and maybe come back to it. But that's actually where I would maybe ask the interviewer for help, right? I would say, okay, I can get this far into my function, but like, is this thing n cubed, question mark, right? And then that means if an n cubed inside an n, is it n to the 4th? And if it's n to the 4th, then that, okay, obviously there's some recursion trick here. And maybe if I didn't look at the code, maybe if I came back to the actual algorithm and thought about like, okay, I'm looking at one row at a time, one row at a time, one row at a time, that would, I'm prepared to venture a halfway, partially intelligent guess that it's n cubed, but I really, the sort of weird way that I'm doing recursion, right? Normally recursion is like split it, split it, split it. And so that's log, it's not that bad. And then brute force is usually like, do a smaller subset, a smaller subset, smaller subset, that's factorial. That's not that bad. This is like this weird combination in between, and I'm not totally sure. And I would actually, I'm going to stick with that as my interview answer and ask the interviewer maybe for some more guidance.
Yeah, I honestly, this is a tough one.
Yeah. And actually, I'm going to even defend myself further, because like, I'm here to talk about interview techniques. I'm not here to talk about computer science, right? So in a real interview, that's exactly what I would have done. And that's exactly where I would say, like, my thinking leaves me at. And if you asked me, said, you have to solve it, Brian, you have to go further, I think what I would actually do is I would move away from the code, and I would come back to the conceptual algorithm. And I'd walk through, okay, what is my algorithm doing? What does it mean to check like one more board state, one more row? And I would sort of walk through it that way. I think getting down in the weeds of the code is helpful sometimes, but other times, like with this, it actually becomes a little confusing.
Yeah, for sure. Awesome. Okay, so I think at this point we're gonna share the code. I think we're out of time, so if people need to drop off, that's fine. Please fill out the feedback form that I posted in the chat, and I think Brian and I will stick around a little bit longer to field any questions that people may have.
Sounds good to me.
Yeah.
And thank you so much for everyone to show up. I really appreciate it. I have not seen all the chat comments right now. Maybe that's good, maybe that's bad, but I really appreciate like everyone coming here. And this is what makes it work well to me, right? Like it's just stressful, but I enjoyed myself, and I'm really happy to maybe talk to you guys now some more.
Yeah, no, that was really, really awesome. That was a very tough question. I don't know if, would you ever ask something this difficult in an interview?
You know, I wouldn't, and not because even if I had a superstar candidate who I knew could be able to solve it, I wouldn't, because it's a lot of time just writing code, and I actually like to spend more time talking about the approach. I would actually ask a much simpler question and then go deeper and explore things in like, you know, a more substantive way. Talk about this data structure. Talk about how you'd profile this. Talk about alternative approaches. Um, you know, I want to be able to have them talk more. I don't want them to just like solve, you know, put gobs and gobs of code on the screen. Also, the final thing I would say is like a problem like this is really variable in that maybe they reviewed it the night before, in which case they're going to nail it. Maybe they reviewed it 3 months ago, and in which case they're going to struggle. And neither of those are really relevant to whether they're going to be good at their job, right? But if they can't talk through their thinking day after day after day, then you know, that's a red flag. Whether they review the night before or not is not something I really want to look for. But that's just me, and I'm going to say like that's my interviewing style. I'm sure that other interviewers have different thoughts as well.
Definitely. And if you were approaching this problem in an actual interview, do you think it's best to start by like building those helper functions, or for the sake of time, would it be better to assume that, okay, I'm going to just say I have this function that will do this for me, and I'm going to try and like come up with the logic of how to actually solve the problem, like the whole can place thing? Would you actually want your interviewee to write that out, or assume that?
Awesome. Yeah, awesome question. So I think by default, I actually like do it's a good design principle, again, of abstraction, like assume it works. And I would completely feel fine if someone wrote a function can place and then the implementation was TBD. And even if they never got to it, that's still good. That still demonstrates good thinking, good problem solving. I'd be happy to see that. If you're doing a case where it's like live coding and you have an interpreter and you can run your code, make a print function, okay? Because like print statement debugging is still a thing that everyone uses, and it's not a bad tool to actually have and implement. But unless you're doing a live interpreter, if you're doing it up on the whiteboard, I think stubbing out your functions is a great idea. Because also, if you're going to make a mistake and you're going to go down the wrong problem-solving path, better to find that out once you've only stubbed out some functions, as opposed to you've ended up implementing a bunch of functions and realizing you never needed them.
Gotcha. And how do you, with a problem that's this big, how do you avoid getting lost in the code?
Oh, yeah. And I mean, there were a couple times here where like I was bouncing around and I was sort of making mistakes, and it's, you know, so part of it would be like, all right, having some, you know, familiarity with like what I was doing and the sort of the general problem solving approach. Even if I, you know, end up with a few more functions than I needed, I can sort of remember like what the important ones were and what the weren't, the less important ones were. I don't know. I don't have a really great answer to this one. I think so one thing, I mean, okay, in actual engineering, and I don't know if you have time for doing this in an interview, right, is stuff like docstrings, right? Being able to say like checks, you know, if a, you know, thing can be placed, right? And that is, I mean, this is actual engineering. This is super helpful all the time. That's how I avoid getting lost in my code in the real world. In an interview, you might not have that much time, but maybe actually leaving in some comments may be helpful, right? So let's say if you stub out a pseudocode, here's how this algorithm is going to work, that might actually be a 2-for-1 benefit. And this may be some helpful tips. I'm not guaranteeing this works. Number one, it saves time, right? Because you're being able to like stub it out in the most high level thing without maybe making implementation perfect. And number two, leave those comments there. And when you want to come back and be like, oh, wait, what is this function doing again? You can quickly look at your pseudocode, quickly look at your implementation, and see whether they match up if you're trying to debug something.
Awesome. Yeah, this is such a hard problem. Cool. Okay, now let's open up to audience questions, either about this problem, about interviewing in general, or about kitware.
Definitely. I have not seen the chat this whole time. I'm going to see if I can bring up the chat here, but if not, Julia, I'll let you be my translator, intermediary.
Yeah. And guys, feel free to unmute yourselves and like actually ask the question out loud if you would prefer.
When we're evaluating the space complexity for this solution, is part of like the recursion tree part of that? I can't remember, like how deep it goes.
Great. So you touched on an important thing, which is space complexity versus time complexity. I want to talk about that first, right? So, those aren't the same, right? They both use the same notation, big O, and the big O is like worst case, right? So you have to assume that like the algorithm takes all the wrong branches. You have to assume that it does all of the, it makes all of the worst decisions in terms of the conditionals, obviously. And one question is like, how much memory does it use in terms of the size of the problem n? That's the space complexity. And how much like time does it take to run? How many cycles does it take with regard to the size of the problem? So you said space complexity, which is awesome. I actually want to talk about space complexity. But most people, first and foremost, they talk about time. Like most people are talking about runtime. But since you asked about space, I'll quickly touch on that. And then we'll also go through maybe your question with regards to time. So again, space complexity, I think that I'm easily happy to say that each of these individual like levels of recursion, right, uses, so first of all, each loop uses n squared because that's what you're storing, right? In terms of this representation of the board. And then in terms of my solution, since I'm making a copy of it, in each level of the loop, I'm making a copy of it, and am I holding on to all those copies at the same time, or am I throwing them away? Actually, each loop, I make a copy, but then the next time holding that copy. So I'm actually throwing it away. So each level is n squared, and each is making a copy, but I'm not accumulating these copies inside the for loop, if that makes sense, right? So each loop, I'm making one copy, but I'm also throwing the one away. So it's like I'm making one, throwing one away, making one, throwing one away. So actually this solve function at one level is still n squared space, and then I'm descending like recursively down, and each level of the call stack is accumulating like a different board, right? And so there's n levels of the call stack, and so the space complexity I'm actually more confident in saying is n cubed, okay? The time complexity, I'm still, yeah, it's a little bit fuzzy, but was that sort of your question, or were you touching on something else?
No, that was mainly my question, except suppose we weren't storing copies of the array, like we just had backtracking happening almost magically. Like, is like the depth of our recursion tree, is that more like the space or time complexity? Because like when you get a Stack Overflow error, it's like the stack runs out of space. I'm just not sure, like, does that go more into time or space?
Awesome question. So here's the way I would think about it. So I think no matter what, you're always going to be spending time, right? Like I mean, if you're making a function call, if you're pushing a new level onto the call stack, and if you're pushing n levels onto the call stack, you're getting n, you're getting penalized for n amount of time, right? I don't think that that's like, that there's too much of a way to get around that. But what we can do is we can certainly pass data, right? Like pass by reference things from like level to level to level, and not reuse memory each time, right? Not make a copy each time. And so I think you can actually get around the space complexity issue, and if you didn't do the copy. So I think you could have a recursive solution where still the space complexity didn't blow up each time. You touched on an interesting thing, which is like call stack size exceeded. And that's, I think, this is my interpretation, and this is not necessarily the correct computer science response. I'm only going to give it my interpretation. There is like, there's some overhead costs to doing recursion, right? When your programming language does recursion, it like pushes this new frame onto the stack, it copies some variables, it does that stuff. And when your recursion gets too deep, your computer itself just like runs out of bookkeeping room, if that makes sense, right? It's like bookkeeping of keeping the stack, but it's not like the actual model, the actual board is being copied, right? So even though we may only have one board that we're working on, we're doing this backtracking, we're like writing some stuff in, we're crossing it out, although the bookkeeping to keep track of where we're at, that's growing unbounded. So maybe some answers would, I could see a world where you say that, yeah, the bookkeeping counts. And I could see another world where it says, no, the bookkeeping doesn't count. It's only the size of the board itself. And honestly, if you find yourself getting Stack Overflows, you've either A, infinite recursion, oops, there's a bug, or B, maybe it's time to move to an iterative solution. Like, I think recursion is an awesome but ridiculously powerful and double-edged tool. But also, when you get really deep recursion, you just start to run out of bookkeeping space, and you need to move to an iterative solution in name of it, like efficiency. Yeah, that's the best I can say. And I'd love to like hear maybe what the official computer science response is, or what you guys think about, you know, about my answer there. But that would be my off-the-cuff answer.
All right, thanks.
Cool.
We have a question from the chat from Akshay. As an interviewer, is the emphasis more on finding an efficient approach or more on our thinking process?
I mean, absolutely the latter for me, right? And I want to qualify every one of my answers that I can only speak for myself. You maybe you go to a company where like you just get an interviewer and they are obsessed with correctness. I can't help you. I would also say that, you know, well, I am obviously coming as that as though it's like a bad thing to be obsessed with correctness, right? Because I'm much more interested in thinking style. That's a biased answer. I'm just sort of admitting that to you. But also I think it tells you something about the company culture, right? Some company cultures might be really, really interested in like, you know, algorithmic perfection and having like absolute like technical excellence at a low level. Cool. And there are people who thrive in that culture and who really love doing that, where like I show up to work, I know exactly what my deliverables are, I know exactly what I need to know to do to knock this out of the park, and it's my job to put lines of code into a repo and get the most efficient solution. Awesome. Like, and if that's your style, I hope you find an interview that works for that, and I hope you find a company that does that. A lot of the problems I work on are much more open-ended. They're much more collaborative. I have to talk to my teammates to figure out what good ideas are and what bad ideas are. I come up with tons of bad ideas every day. I talk to my colleagues. I tell them like, hey, what do you think? I get feedback. They come up with lots of ideas of varying quality. They talk to me. If you enjoy that sort of problem-solving environment, I hope you find a company that interviews in that style and actually works in that style. So I think actually it sort of makes sense to have both styles, because you also have companies and jobs that require both types of work.
Okay, here's another question that a few people were interested in. Hey, Brian, I wanted to try to contribute to some open source projects. I find it more difficult to contribute to existing projects rather than coding something from scratch. Do you have suggestions on good open source projects to contribute to?
Cool. Great question. So one thing I will actually happily mention is a thing called Hacktoberfest. So every year I do this, and they send me a free t-shirt. But this is a thing that happens in October, right? And they're all about like getting new people involved in, you know, in software. And what happens, again, this only happens in October, and then maybe we'll think about how to generalize this the year round, is they walk you through the basics of like how to come up with a GitHub account, how to, you know, make a pull request. And then they encourage maintainers of projects to label projects as like good first issue or good first whatever. That's so you can, and there are a lot of other things that are similar to this, where they are like basically onboarding like facilitator services, where they take open source projects who have a need for new contributors and are willing to label and like provide tutorials and provide assistance, and they try to match them with people interested in getting involved. Here's how I realistically get involved in a lot of open source things. I actually use a library, and I discover like some opportunity for improvement, right? And it could be like a really small tool, it could be a really large tool, it could be just like try out other people's stuff that are in an area that you're passionate about, in a project that you're working on, and you maybe realize like, oh, I used your library to do X, and I ended up having to write a function that did something else. Wouldn't it be nice if like that function was contributed upstream? And I'll give you a couple more like sort of soft tips. The open source ecosystem is a wild west. You'll find some projects which have absolutely amazing communities. They're super welcoming and they're super helpful. You file an issue, one of the maintainers responds to you, you make a pull request, they'll give you feedback. Other times you will find things where it's like a tumbleweed, like desert, right? You make a bug report, no one answers. you give them a pull request with like, here's a perfectly working bug fix. Here it is, you're welcome. And like, no one answers you. And my advice would just be like, give up and try again. I don't think there's a magic like formula to what communities are welcoming and what communities are kind of dry and kind of don't have a lot going on. But I would say just like try to contribute to libraries that you already have some passion about. Don't go into some project that you don't have any interest in and you don't have any knowledge about and expect to like, contribute, because realistically, who wants to do that, right? Who wants to just write random code about a thing you're not interested in?
Awesome. Thanks for that resource. I will also send that out in the email. I have a question.
And I have no affiliation with them other than they give me a free t-shirt. But I know there are a lot of other things like Hacktoberfest that try to match up like people interested in contributing with repos. Yeah, sorry, go ahead, Julie.
Sure. I was going to ask, at the end of an interview, is it okay to ask your your interviewer for feedback, and what's the best way to do that? And then also, have you received any questions during an interview that were really out of the box and made you think and like stood out to you?
Yeah, great. For me personally, I'm usually happy to give some basic feedback, right? I try to, realistically avoid getting too much into the weeds, because in the day, like, I'm sorry guys, like I'm happy to take my time now, but like when I'm interviewing, I'm on the clock. My job is to find the best candidate. My job is not necessarily like, to help people improve. But I want people to improve. Like I want to see more candidates. I want to hire more like amazing engineers, no matter, where they're coming from. So I try to give them some basic feedback of, oh, hey, you could have like communicated this more, or, oh, hey, I really liked when you said this. And personally, when I do an interview, I try to set some expectations at the beginning. I say, so, hey, I'm going to ask you to solve the end-means problem. And what I'm really looking for is for you to talk about this, is for you to talk about your design process, is for you to talk about alternatives, is for you to, like, to me, I'm not trying to have trick questions. I don't want to like come across like there's some magic criteria that I'm not going to tell you about. I think most interviewers won't do that. So it's up to you to be like kind of outgoing, and up to you to put yourself out there and to explain yourself. But I would say, as long as you ask respectfully, I don't know. I mean, I'm not telling you that no one would take it the wrong way, but again, are you really so desperate to like work at a place where if you ask someone politely for feedback, they hold it against you? That sounds to me like a pretty rough policy. And then as for the second part of the question, what was that?
The second part was, have you received any questions at the end of an interview that like really stood out to you?
Yeah, I don't think I've received, I mean, one person asked, like, I did an interview recently, and one person asked a weird question about like, hey, with like COVID, is that impacting like the financials of your company? And I had to be like, it's a little bit outside of like my wheelhouse. That's not something I really deal with. Like I deal a little bit with like government funding agencies and research grants and stuff, but like, yeah, not really. But usually, I mean, I usually get the basic questions of like, tell me more about the day-to-day of your company. Tell me, what don't you like about your work? What do you like? What sort of projects will I work on? And I usually have, like, just for the experience, a lot of answers there. I will also just, maybe this wasn't quite the question, but sometimes I've gotten questions during an interview that I don't know the answer to, right? And I'll tell you what I do personally is I just say like, I don't know. I'm not there trying to like look smart to candidates. I will usually try to interview people about at least one topic where I know that I know more than them, even if it's some like incredibly obscure thing, just because I kind of want to see how people react when eventually they reach the limit of their knowledge. Like I want people to be able to say, yeah, Brian, that's a good question. I'm not sure. Here's how I'd find out, as opposed to like, break down and just not be able to handle it when they don't know the answer to something. But yeah, I'm happy to walk through people and to, if I were solving this collaboratively with someone and someone got stuck just like I did, talking about like, what is this, the space complexity, I would talk to them too. And I would say like, excuse me, actually, I meant time complexity there. I would say, yeah, I don't know either. Like, good point. Let's talk through it. I think that the more important thing is how well you can communicate with other people.
Yeah, awesome. Great feedback. Thank you. And Let's see. Do people have any more questions? Okay, well, I have another question. If you're applying for a job and a company has an optional field for a cover letter, should you submit one?
Good question. I mean, I think my answer is like, it probably can't hurt, right? So a cover letter is, so who knows, right? In that it's possible that the particular resume review system that this company uses, the people who matter will never even get the cover letter, right? Or like, because there are always those weird things. But a cover letter, I mean, in general, is your chance to really personalize things to this company. So I think it helps to have like maybe a short little blurb. This is like the text version of the elevator pitch of like, hey, I am AX, right? And that should be like a 3 to 4 line paragraph just talking about the basics of yourself. But then also, if you have done some research about this company and like you read their website a little bit, or you know something about their products, or you're passionate about the things they're working on, include that. And a cover letter seriously can be basically like 2 paragraphs. One where you talk basically about yourself, but in like more text form, and one where you say why you're excited about this company. And that, like, if it takes you, 30 minutes to fill out and do the application, it could take you an extra, 5 or 10 to maybe write up a little paragraph customizing yourself to that company. But it could really make a difference, right? And it's definitely not going to hurt you. So if you're trying to go in for a shotgun, I want to apply to 50 different places approach, okay? I don't know how sustainable it is to come up with a cover letter for every one of them. But if you're applying to like maybe 4 or 5 companies and you're like just really passionate about all of them, yeah, definitely put together a cover letter, write it up, do something in like a Google Doc, PDF-ify it, and throw that in there.
Cool. How do you deal with imposter syndrome, especially during technical interviews?
Oh boy. I mean, I think that is like, that seems to almost be like a universal among engineers, right? I felt, I'll begin. I'm going to be honest in transparency. When I couldn't answer like, the time complexity question about recursion, I felt really dumb just now, right? I was like, what's going on here? Like, I'm supposed to be here, like helping to be an expert, and I can't answer this question. Like, that is fine. I think everyone, like the smartest people I know, people who are smarter than I do, have told me they experienced that. So one is that it's normal. And the other one is like, I think, again, companies aren't in the interest of like judging you negatively. They're in the interest of like filtering out and like coming up with the most appropriate candidates. So if you think that there's a company that's an absolute stretch, it's an absolute, like, there's no way I'll make it, I'm not good enough, again, apply anyway, right? And if they want to reject you, if they really think you're awful, believe me, they will do so as quickly as possible, okay? Because they don't want to waste their time. If you get a second interview, if you get a first interview, if you get a second interview, if they're following up, take that as a sign that like, no, they don't think that you are out of water. Like, they think you might belong. Companies are not in the business of stringing along people who they think are out of their league. So any success that you have, take that in the best possible way, because like the cruel corporate, like efficient world of business is not in the business of stringing people along for their emotions. So all good news should be taken like quite seriously.
Daniel asked a really great question in the chat. What are some indicators of a really good engineering org?
Yeah, great. And by the way, I love this quote from I can't really pronounce the name, sorry, but like, let the company do the filtering, don't do it yourself. Absolutely. Yeah. Good. Yeah, Ezra, thank you. Yep, agreed. Indicators of really good engineering work. I don't know. Good question, right? So yeah, I mean, it's kind of like, I would say kind of similar, but definitely not the same indicators of like a good, vibrant open source project, right? I would say like good communication, people not afraid to talk to each other, to collaborate, people not afraid to hash ideas out and discuss ideas, right? You shouldn't be afraid to like suggest something, even if it's a little bit weird, or even if it's a little bit, maybe even a bad idea, as long as it stimulates an interesting conversation. I would like to think some like some mission, some goal of like, here's the type of like culture that we're trying to create. Here's the type of software we're trying to build. I mean, even my company, we work on like this variety of different domains and different areas and different types of software, but we still have a basic core mission of like, we're advancing scientific knowledge. We're working with researchers. We are, you know, doing our technical best. I think having some sort of mission other than like, you know, we're just here to maximize the number of lines of code we write every day. I think that helps because I think at the end of the day, having passionate people, passionate colleagues is going to make things a lot better. I think the better question, or even an even better question, would be how do you figure that out, right? How, and I'm gonna ask this: how can I, as an interviewer, figure out, like, filter out good companies, right? I need to filter them out so I can figure out where to apply to. And if I'm in the lucky enough case to have a couple different job offers, how do I filter out where I want to go, right? I mean, if you've got, you know, 3 summers or 4 summers of internships to do in your entire college career, that's a pretty limited opportunity, right? And so I'm going to ask and answer my own question of like, don't be afraid to ask like respectful questions, right? You know, what do you enjoy about, I mean, even if you don't ask like, what do you hate about your job? Just be like, what do you really enjoy about your day to day, right? You know, what do you think, like, you know, what sort of candidates like at this company do best, right? And you can always have like a positive spin, right? You don't have to say like, so tell me about all the awful interns you've had. You'd be like, so tell me about interns you've had in the past that did really well. You know, what sort of things did they bring to the table? What sort of projects did they get done? I think you should not be afraid at all to ask questions if given the opportunity. And yeah, and before the interview, when you're doing the filtering, I would say, I mean, it's tough, right? Look at their website, but I don't really have good advice there. I'd be happy if someone else wants to post in chat, like if they have any good advice for like how to filter companies, right? Both to get ones that like are realistic for what you're sort of looking to do and also are a good learning environment.
I've always found like questions that I find really helpful to ask is what do you like, what's your favorite thing and your least favorite thing about your job or about your
Oh,
company?
by the way, Stefan mentioned Glassdoor, which 1000%, yes. Glassdoor is a great resource. I forgot that one, and I would agree. Check them out. So I mean, and those who don't know, right? I mean, I think most people know Glassdoor, but like that's where people who have either like been employees or actually been interviewees post reviews of companies. And definitely check that one out if you have any like concern. I think you do have to pay to get like some of those like detailed information, but I think you can get basic information for free.
And then one other question that I would recommend asking is about the turnover rate, because if people are coming to the team and then leaving quickly, that shows that they're not loving their time there and they're like anxious to get out. Or maybe there's other reasons, but if there's a high turnover rate, that doesn't look good. If people love their job, then they tend to stick around.
Yeah, I agree. I mean, I think that's a really good point. It might be difficult to get that answered. I mean, I'm not sure if every engineer would even know those sort of numbers, but you could even ask something like, yeah, and Ezra, you're mentioning like, could you ask that? I could be like, so how long has like the average employee been with you? You know, like that's just an idea, but like it's kind of a neutral phrasing of the question. Turnover rate sounds a little bit negative, but like if you're like, you know, so how long has like the average employee been with you? Do you have a lot of new hires? Do you have a lot of like people who've been here longer? And that's probably an easier question for like an actual hiring manager to answer. I don't think many of them would necessarily know like statistics off the top of their head.
Gotcha.
By the
Yeah,
way, someone's also saying I'm breaking up. Julia, if you hear me breaking up, let me know, but it might be on their end.
you sound fine to me.